Welcome back. So there's one last video for ANOVA. I know this lesson is longer. It's about 1.5 of a regular lesson. So that should be put into the calendar accordingly. But I want to cover a few last loose ends. One of them is I want to go over the patterns again in the ANOVA table, the patterns and the vocabulary, because it does take a while to get all of these symbols down. So first I want to look at the pattern and the common abbreviation. So we have talked about the number of groups is K and the total sample size is capital N. Okay, so we're going to be using those. And then the first row in Staplet anyway is called group, but you might also see treatment in some apps. Okay. So for the group, the degrees of freedom is K minus 1, so the number of groups minus 1. And then the sum of squares, that is the SSG. So that's the thing we found called the SSG, and that comes from sum of squares group, right? So we're actually getting the letters from here, sum of squares group. And then the next, then we divide that. So then we take that SSG over K minus 1, and we get the MSG, okay? It's not what you put in your food, but it's the mean square group, okay? Mean square group, okay? And then, so that is the variation between. That's the abbreviation for that. Okay, and that's the numerator. So that's the top, and this whole second row is going to be the bottom, which is pretty handy. So then in the error group, so that is, think standard deviation is error, or just variation, normal expected variation. Capital N minus K. And then it's interesting, these will add up to capital N minus 1. So if you think, if you subtract K, well, let me just do it down here. I got a little bit of space here. If I did, if I add these up, so K minus 1 plus N minus K. Oh yeah, for some reason I thought they were being subtracted. But my two K's, we have K minus K, so those cancel out. So we end up with N minus 1. Interesting, huh? So many patterns. Okay, so back to the error row. Then the sum of squares for the error is called SSE, and that's the numerator of that second fraction we calculated, right? And then we take the SSE divided by those degrees of freedom, SSE divided by N minus K, and then we get the MSE. Okay, and that's the variation within. Okay, great. And then we saw that we divided these two numbers, the MSG by the MSE. And that gives us the F statistic. Okay, and lastly, we found the p-value, which always is a probability, right? The probability that our F statistic, or just F, is greater than the number we got. We'll plug in our F value there. Maybe I should have reversed those two, I don't know. So that is what we saw in our example when we kind of notice these patterns. If you take this divided by 2, you get that. This divided by 72, you'd have to do that one, but trust me, it works. And also these add up, but I don't think that number is very useful. Then you divide those two and you get your F, and then use the F distribution to get your p-value. Okay, so I hope that helps, just like a little refresher of the patterns and notation there. Okay, so let's talk about another thing. So another thing is just another way to get our total x bar. we had a spreadsheet with all the data in there, right? But if you don't have the raw data, if you just have your summary statistics, then you can still find it, okay? So if you have, this is for summary statistics only. Statistics given, no data. Okay, what you can do in that case is you can weight each mean by its sample size, right? So if you multiply each mean by its sample size, add all that up, and divide by your total sample size, you will get the overall average, okay? The way this works is, so to get an x bar, you add up all the values and divide by n, right? So then if you multiply back by n, you get the sum of all of those data values. So you'd have the sum of the first group, sum of the second group, sum of the third group, divided by n. So just a little bit different way to do it. So in case you run into a problem where you don't have the raw data, you just have the summary statistics, you can still find your capital X bar. Okay, so now let's get to those confidence intervals. I mentioned something about the confidence level, and I also want to give you the formula in case you're curious about the formula for those confidence intervals, okay? So we mentioned this in the last video. When we reject the null, that tells us that at least one of the means is different, but it doesn't tell us which one, right? So we can use Staplet, and these are called the Fisher's least significant difference, or LSD, okay, not the drug, but Fisher's least significant difference intervals to determine which means are significantly different, okay? So a little bit about this method, in case you're curious. This method uses the square root of the MSE. So let's go back up. What was the MSE again? MSE was the overall, remember, average, in quotes, average variation of all three groups, right? So that's a little interesting. It's using the square root of the MSE from the ANOVA as the pooled standard deviation. Okay, now we can kind of do this because we have this approximately equal spread condition. So what it's doing is it's using, instead of calculating the pooled just for each pair, think how long that would take, right? Might as well do a paired t-test for each one, for each pair. So what they're doing is they're using the pooled MSE of all the groups for each pair. Okay, so that's kind of interesting. It is a bit of stronger test though that way, just because we're using all of the groups rather than just the two groups, okay? And we're using the degrees of freedom for all the groups. Okay, so there's the formula. I'm not going to have you calculate these by hand, okay? But just in case you're curious, you know, inquiring minds want to know, right? So that is the actual formula. I did a test and it works. So in case you are curious. Now, this is called the LSD intervals. But I mentioned there was an issue with the confidence level, right? So let's talk about that. When we're comparing many confidence intervals, there's an issue because the chance of a type 1 error for multiple comparisons would end up being larger than our original significance level. So think of it this way. We did 3 different confidence intervals, all at 95%. So that is just doesn't quite match up to significance to a one-tail test of 5%, right? So it's kind of a mismatch, okay? So in order to fix this, we can adjust our confidence level by dividing the significance level by the number of pairwise comparisons we're making, the number of intervals we're making, okay? So when we do this in combination with the LSD intervals, it's called the MSD. So really what we want is the MSD, or minimum significant difference. Okay, so many abbreviations, I know, but we are basically, my point in doing this is just to show you what Staplet is doing and use Staplet, okay? But we do need to, instead of putting in the 0.95, we need to adjust that, okay? So in this case, we had 3 pairs, right? So we're going to have an alpha star. So it's a little different alpha. So we had 3 pairs, or 3 intervals, and you'll have a different number, so you can always run it and see how many you have, because it gets, there's a formula for that, but we don't need to go into that. So we had 3 pairs, so we need to take our alpha star is going to be our original alpha, 0.05 over 3. Okay, 0.05 over 3. So this is a one-tail test, so actually we're only counting the one tail, versus we would adjust if there are 2 tails in the test. So 0.05 divided by 3. And then I'm actually not going to divide because I'll get a repeating decimal. So I'm going to go ahead and do my C star. The confidence level, just like you're used to, is 1 minus alpha. And I'm using that because there is only one tail on this test. There's not another tail to combine. So I'm going to do C equals 1 minus 0.05 divided by 3. Okay. Get out my calculator for that. Okay, 0.983. So now I have a confidence level of 0.9833. Okay, or 98.33% confidence. Okay, so that's what we want to do with Staplet. So I want to write up here, we're going to use technology. Okay, but we are going to use the adjusted confidence level. That way it matches our hypothesis test. And I'm going to make it part of the practice to change this and do it for our example. And so you can see if there still is a significant difference between every group, or if just one is different. Okay, and also I'll have you summarize what the differences are. Okay, sounds great. Thanks for watching, and I'll see you in the next lesson.